I work for GitHub, and I work and help them build agentic systems. One of the agentic systems that I work on is the LangChain4j library, LangChain library, and it allows me to actually go in and create agent workflows. But to understand how to create this game and these agents, I had to understand how the matrix worked. You see, an agent has rules. They're not allowed to bypass the rules. Later on in the other movies, Agent Smith actually did that. And their strength and their speed are still based in a world that is built on rules. And this was Morpheus, Neo's champion, really, that tried to get Neo to become the one. We're going to see exactly, can I code something that can beat these agents? But to do that, I need to take a step back, because the word agent is actually being used many times, and I think it's a little bit of a buzzword. So you've got your simple chatbot, and your simple chatbot will then just speak to a large language model, and you're just going to send it your information, and then hopefully it remembers what you said. Now, what is an AI agent? Now, if you watch the movie The Matrix, it was by Warner Brothers, 1999, you'll know that they can kind of reason, and they can kind of act, and that's called the react pattern. They can react to stimuli, they can react to information, because they can remember, they can maintain state across interactions, and they can collaborate. They can actually work with other agents. I'm going to show you how today. And then that is going to give a result, and then that is going to send it back to the user. So with LangChain, or LangChain4j, we're going to focus on LangChain4j. Then you have your agentic scope. It's basically your variables in memory, or you can put it in a database. And then that's going to use your system prompt to set the role, personality, and constraint. I've set the Agent Smith. There's a very angry agent there. And then the LLM, I'm going to be using GPT-5 Nano for the game, but I'm going to show you how Mini actually works with some of the patterns. And then you've got your tools, and I'm going to show you how to do tools there, calculate a web search or database queries. And then you've got your output key, and that's going to output to agentic scope. That's the basics of any agent. But then once you have that, you can add your dependencies. So you're going to add your library. You're going to configure your LLM. You're going to define your agents, the roles, goals, and tools. And then you're going to choose a pattern. Pattern? This is about agentic patterns. And you're going to wire your agents into using the pattern that best facilitates that agent's purpose. And I'm going to go through those patterns with you. And I'm going to go through each one, and I'm going to show you an example of that. In tier one, we're going to go through workflow patterns, if, then, else, sequential, parallel, loop, and conditional. That's exactly like an if, then, else statement, and how you can use that. Then we're going to look at agentic patterns where the LLM decides, like the supervisor and the human in loop. And then finally, we're going to check some really advanced algorithm optimized patterns like the GOAP and the P2P that allows you to use emergent behaviors to go from low autonomy to high autonomy, and also simple to advanced. So in this example, I'm going to go through the 8 patterns, and we're going to go through sequential, parallel, loop, conditional, supervisor, human in the loop, and then GOP and P2P mesh. At the same time, I am going to give you a demo. I'm going to run it locally on my PC, but I am going to give you a demo to play around with so you can actually go in and try each one of those. So the first one we're going to use on the demo, this is the demo that I'm going to give you, is the sequential pattern. What the sequential pattern really does, it kind of chains everything together. Now, you remember that word LangChain? So before OpenAI came about and they created ChatGPT, people used to chain prompts together, and that's where the name came from. And this is very similar. You've got a chain. So in this case, we've got a creative writer. It's going to generate a story. Then an audience editor. It's going to adapt for the audience. And then the style editor. It's going to polish the style. All this time, we are going to use agentic scope, which is going to take the story, the adaptation for the audience, and the style. So let's go into our code. And this is, I'm going to send you the repo here. And this, most of the code you don't have to worry about. We've just got the execution service, which actually goes in and edits that. So I'm going to start this out, and then I'm going to show you the actual code. So let's go into there. So here's the showcase. It's running locally here. And then I'm going to hit sequential workflow. And what I've done is I've wired it to a WebSocket to actually give us events real time. And I'm going to say, write a fantasy story for teenagers in a humorous style. I'm going to execute the pattern. Now we're going to watch the event logs here. And what I've done is I've said, okay, cool. Every time you call in a agent, go tell me. So the agent invoked is the novel creator. And then we've got one generate stories. I'm going to come back to that now because I'm going to show you the code that we've got here. So this is execute sequence. And don't worry too much about the Java code. I'm just going to show you really the code that we're going to do. And you can see it's running in the background there, localhost. So we've got our creative writer here. And if we go into our creative writer there, you can see there, it's got a nice prompt and it's got the topic there. And the topic is going to actually go in, and that is going to be added to the agentic scope, the scope of that. So the topic's going to be sent in, and then we can actually go into our next one, which is the audience editor. You can see there, edit for audience. There's no topic there, but there's the story. If you remember there that we're going to output from one agent there, output key equals to story, and that's going to pick it up. So one agent then chains to another agent via the agentic scope. Then we also have a style editor that's going to take the story. And then we've got the novel creator, which is going to take, and this is an interface to say, go in as an agent and go in and create a novel for that. So we've got the sequence editor. Let's just minimize that a little bit there. The audience editor, the style editor. And then what I do there is I say, build a sequence. And we call it a sequence builder in LangChain. Build a sequence of the writer, then audience, and then style writer. And if I put it in that order, it's going to call it one after the other. But then it is also going to have a key right at the end called story. At the same time, I'm going to call a listener there, and that's the events that you see here. So if we go back into AI agents, you can see there that it's actually complete. And every time it does an event, that's the listener that I sent there. There's the actual story that I got. It took 77 seconds. So it's very slow sequence because you're doing one, you're processing it, you're calling LLMs on the second one, then you're doing another one. So it's pretty slow there. So that's all right for a game if you wanted to do something long. But let's just go back into here. And then I've got my final, and I got completed and the actual sequence. And that's the sequence workflow. Kind of boring, but it also kind of gets the job done. The parallel workflow is blazing fast. It's blazing fast because the two agents, in this case, we're going to ask for a romantic evening with both a food expert and a movie expert to recommend food and movies. They don't know about each other. We're just running it there, and then you say, don't stop for anyone, just go in and run it. Now, watch the speed difference that we are going to get here. So let's go back into our workflows here, into our parallel workflow, and let's plan a romantic evening with movie and meal suggestions. We're going to execute this pattern. So this is going to take about 12 seconds. So if I go into the execution service here, and go a little bit down, the next one there is execute parallel. And what I'm going to show you here is that I actually run, so create a Agentic system, and then I've got a event planner agent. That event planner agent actually says, go run these parallel agents, the food and the movie expert immediately. Just go run it, and then give me the output key for the plans it goes and creates. The plans are really just a randomized version of a meal and also movies though. So that actually is incredibly quick. And you can see here, 13 seconds. And here's the evening plans. Let's go a little bit down there. The movie, before sunrise, cozy Italian, and then the meal, scared scallops with lemon butter and asparagus risotto. I would have chosen pizza. It's a cozy Italian movie, but at the same time, they don't talk to each other parallel. Blazing fast, they don't talk to each other, which is kind of different from the next one. No, we still got one more to go, the loop. So imagine the movies and the food would go around, and I would actually critique it. I would say, I need a style. I need you to actually come back and say the score for styling it is of a certain criteria. So in the example that I'm going to show you, let's go back into that one there. And now let's go see the loop one. Now the loop can take a little bit longer because I'm going to loop max iterations 5. Agents 3, and it's the creative writer, style scorer, and style editor. write a story about dragons in a Shakespeare style. We're going to execute that. So what that is going to do, it's going to go in, let's go here, and it's going to, let's close that there. It's going to go score it and only return, hopefully, and this is a live demo, so I'm hoping that that is going to come back soon, and execute the loop. And I'm going to say, okay, here's my agents here, here's my creative writer, here's my style scorer, and there's my editor. Now, run this in a loop until and output the score until the actual score, and we can see here, let's go final score, until the final score is above 8, greater than or equal to 8 there. And it's going to run it. So you can see there's an exit condition there. And go read it, the score, because one of the agents is just going to create a score. And eventually, after these finish the scorer and refiner, it's going to have a score. So we can see here on the, let's see if it actually did the score here. Oh, okay, it took 44 seconds. The score is 0.9, so way above what I wanted it to exit. So it exited it immediately here. And you'll see it waits for this. If you go right to the top here, we're going to create the story. So generate the story, and then get into a loop, style review loop, score it, edit the story if necessary. So it actually did, it actually scored, it came a little bit low, and then it actually said, okay, score it a little bit higher. We're editing the story, and then we score the style. Oh, wow, that's a bit low for the score style. We edit the story again, and then we score the style, and then we got it. And it did like 3 or 4 times there. So that's a loop that allows you to actually go in and increase the style and the score, and loop it until it gets to the right point though. Conditional also is very similar to what conditional does. It says, here's a category router, and here's a bunch of agents. I want you to compress the prompt that the person gives me, and then go in and choose the actual agent that we want for our prompt. So let's go back into our demo, and let's go into conditioning router. And now I'm just going to say, what are the symptoms of diabetes and available treatments? I don't want it to send to a legal expert or technical expert, but I'm not going to say, please send to your specific expert. And let's go execute patterns. What it's going to do, it's going to classify this, and then it's going to go in, and let's go into here. It's going to classify it with the classifier agent. So we've got the conditional agent here. So we can go into the category router, and it says analyze the request and categorize it legal, medical, or technical. Once you've done that, then go get the medical expert, the legal expert, and technical expert. Go create an if statement to say, listen, if the actual category that you categorize is of medical, go call the medical expert, go call the legal expert or the technical expert. Then go and this I found absolutely fascinating. You compose the router and conditional in one sequence, and you say with the condition and also the actual agents, I'm going to execute you in one go. And you execute it, and you get everything back, and you'll see here that we should have actually gone expert router, there it is. And then, okay, let's go back here. Expert router classifies it, and then it classifies it as medical. And then it goes in, runs the conditional, says, do you have a medical? Yeah, I've got one here, cool. Go call the medical agent, status updated, and then it's going to complete all of those agents. And there, it says, I'm not a medical information resource. Of course, it's going to disclaimer. But the information below is education and not for medical advice. And they'll tell us about diabetes. And that is the conditional. So we've seen all of the basic if, then, else statements. So we saw sequential, parallel, loop, and conditional. Now let's get into something a little bit more exciting. Supervisor agent. So I'm going to execute that. I'm going to say transfer $100 from Mario to Georgios, then convert $50 to as euro. And there's so many agents here, withdraw agent, credit agent, exchange agent. Let's execute that. Now I'm going to go back into here, and I'm going to go into the supervisor. Now watch what's happening here. I'm going to create banking tools. So if I go into the banking tools knows how to withdraw money. We also have a exchange tool that knows how to, it's just hard-coded there, exchange that. And I've got the banking tool and exchange tools. And what I do is I create a agent, withdraw agent with those tools. I just go in there, and those tools are pretty simply just annotated with a little annotation there. No, let's go banking tools. Oh, okay, yeah, there's tool there. So it knows, and it knows how to actually call those tools though. And then we say, okay, there's the withdraw agent, it's got its tools. There's the credit agent, it's got the banking tool. So there's the exchange agent, and that's the exchange tool. Now the supervisor here is going to take the withdraw agent, the credit agent, and the exchange agent, and then it's going to write a summary. What the summary is, it's going to say, hey, I've spoken to all of these guys. I helped withdraw, I helped exchange, and this is the summary of what we did here, and get the results here. So we should see the supervisor agent actually talking to us. And then it says, yeah, I transferred $100 from Mauro to Georgios. Mauro's balance now is $900 and Georgio balance is $1,100. And then I convert to 50 USD to euro, 46 point euro. This took 36 seconds, but that supervisor agent, that's kind of an agent taking care of an agent. Yeah, agentception. So now we've got the supervisor agent. And yeah, sometimes, you know, we don't want to lose our job too much. We want human in a loop. So we're going to execute the pattern here. And this is going to use WebSockets and also the LangChain4j. And I'm going to say, what's your star sign? I want to do your horoscope. And I'm going to go, I am a Virgo, born 15th of September. And it's going to come back to me. And now I can actually see here in the human in loop, pretty simple here. I'm just going to go create a extractor here. And then I'm going to go, wow, okay, go create a, you don't need to worry about that. Human input service, their request input though. So if you go human input service, what is that there? And that is going to, if we see here, that's just going to say provide the input and then go in and send the results. Let's go back here. Let's go back right at the bottom. I've got a very fancy mouse that can really spin fast. And we want human in the loop here. And it's going to go, that's the Virgo, and then going to go call the agent that is going to go in and call the horoscope agent. So pretty simple horoscope there. And I should have I'm hoping for very good news here. The universe is smiling in your careful heart and keen mind. Yay, positive horoscope for me. And that's human in the loop. So next, we were going to go into the two final patterns, and I'm doing very well for time now, the planning patterns and also the goal-oriented planning and peer-to-peer. Now, these are a little bit complicated. I mean, when I go in here and I go, plan a trip visiting Paris, London, Rome, Berlin, and Barcelona. If you've ever traveled in your life, you know that that's very hard. And I want the distances, the attractions that I can do, the route optimizer, and the itinerary planner. So I'm going to go execute the pattern. This takes about 100 seconds. And then I'm going to go into my execution service here. And then what it's going to do, you can see I've even written it there. It's going to go in, and I'm going to create the city parser. I'm going to create the distance calculator, the traction finder, the route optimizer, the itinerary planner, the normal agents there. But then what I'm going to do is I'm going to create a planner builder. And I'm going to give it the sub-agents there. And then I'm going to say to it, please go use the goal-oriented planner pattern. And this is using a algorithm, and it creates a graph of all of the agents. And also, in each agent, what is the keys that they need, the outputs there. So if you see here, the itinerary planner right at the end has the highest cost. Let's go into the slides I can actually show you here. That has the highest cost. So here, the goal-oriented pattern, the cities here, to go from city parser to distance calculator only has one. So we can actually run those in parallel. But then from the attraction finder to the route optimizer costs 2. And then from the itinerary planner, 3 cost. It builds a graph. And then it says the easiest way for me to actually run this is to actually go first and call city planner, distance calculator, and attraction finder at the same time, and then route optimizer, and then itinerary planner. And we can see how that works here. So if we go into here and we see the event logs here, it's still running here. It's optimizing the route. Let's go here. So it's going to go call the goal-oriented planner. It's going to invoke the past cities. So which cities am I dealing with? It's going to calculate the distance between the two, so it can work out what is the optimal traveling distance between the two and there. And it's going to go, okay, that's the distance between the two of them. Find attractions in each one. Okay, it came back 121 seconds. Find attractions in each one of them. Let's go back a little bit there. So yeah, so it found all the attractions in each city, and then optimize the route, and then plan the itinerary, and give the actual result here. And here's the results. So day 1, Paris, attractions to visit, and then it's going to give you your attractions, and then your practical tips of what to do, and then it's going to say, okay, day 2, you need to travel on the Paris to the London Eurostar, and go in there and how long it's going to take you. And it goes right to the end of the itinerary, and it tells you exactly how long it's going to take. So 10 days, you can do 4,135 kilometers. If you want to do a slower pace, 10 days and everything. And this is a magical way to actually do planning, trip planning with a goal-orientated planning. And the final one, before we actually see what I chose for the game, is the peer-to-peer. So imagine an agent just sitting on a box somewhere, and that agent only comes alive when some condition is met, and that condition is its variable it needs to process. So let's just say it's waiting for a city. When that city is in the shared agentic scope across maybe multiple PCs, it's just going to come alive. So what you can do then is you can build emergent behavior. Think thousands of these agents just coming alive at any given time. And it's great for collaboration, for research, for brainstorming. And in this case here, what we're going to do is we're going to have a literary agent that is going to create a hypothesis, get a critic to critic it to a score, validate that critic there, and also use a separate scorer agent there to actually validate the literature. So validate the hypothesis, validate the scorer, create a end-to-end hypothesis machine. So to be able to do what the academics do. So if we take that and we go execute the pattern here, research the effects of caffeine on cognitive performance. I want research. I want to be able to say this is the hypothesis, score the hypothesis, go score the research also, come back to me with an actual, can you actually take caffeine and help cognitive performance? So let's go back into our execution service. It's a very simple way that we're going to do this, because you see here, that's the last one. In P2P, we've got our literary agent, we've got our hypothesis agent, critic, validation, and scorer. And all we're going to do here is we're going to say, here's a workflow that we're going to do. Those are the sub-agents we want. And just carry on doing this until you get a score, a max invocations 10, of a certain score. It's 0.75. So you can't let it run forever, because I mean, like, that's going to take days and everything. So I've said maximum 10 times. We saw the conditional. Remember the loop that we did there? It ran about 3 times. Hopefully it won't take that long there. But max invocations 10, and then make sure that the scoring for the hypothesis score is valid though. And then we're going to just publish our results though. So that's kind of all that you need to do to make an emergent agent behavior. So let's go into the event logs here, and let's see exactly what's going here. Let's make that a little bit bigger. Oh, there it came back in 82 seconds. Let's go back to here. So we've got our planner, we've got our research, and it's given our research. And then after that, we formulate a hypothesis on that. We critique it, like bad hypothesis. We score it, and then we go in there, we critique it again, and then we get the result then. And then the final result, hypothesis in habitual coffee consumers, an acute 200 milligram, that's a lot of coffee. Caffeine dose can produce true pharmacological improvements in sustained attention and simple reaction. And you can see this is quite considerable here, and we've got a 0.88 out of 1 score, the target score announced. So now that I've got that, now I've got a game that I want to create. So if I go into my presentation, I've only got a few rules here in this game. So I want to create a ability for sequentially the agents to attack Smith one after the one. So each output feeds into the next. I then want to actually create parallel to see, can I actually, attack Smith and beat him if I were to attack him at the same time. And then finally, I want to see if I'm lucky. And I've run this once. I want to do auto battle, which is the loop pattern. I want to fight them until Neo wins though. So let's go into the the game here, and I will give you the URL so you can actually play with it yourself here. Here, this is Agent Smith. I called it the Smith here. And you can see there, I've got a little checkbox there to say Neo is the one, and that will actually empower Neo. Think like, Super Saiyan mode, and he will get lots more power. And then I've got Sequential and Fast here. So if I go Sequential and I go Fart, now, these it is pixelated because I wanted to focus on the actual agents there. So Neo overpowers Brown. Oh, so Neo won. I haven't even put Neo as the one. Let's see if Jones won. Jones lost also. I actually might win this round. Oh no, Smith beat him. And if one agent beats them, you're going to lose. And that took about 10 seconds. So now let's go in. Let's reset that. Let's do fast mode, and let's go see what the difference is. Hopefully Neo can win there. And let's do fast mode. Now, watch the difference between them. We're just going to hit them in one go. Whoa! Oh, Neo lost, eh? Because actually Brown and Jones beat them. Smith didn't even try. So now let's switch on. Let's reset and go. Neo is the one, and hit fast mode. So now we're going to run that. And now hopefully Neo wins because I've just given him more energy. Yeah, he won. He won all of them. Neo overpowers all of them. And the actual code is pretty simple. We've already been through how to do sequential parallel. So sequential here, we're going to actually set up the agents there, Jones and Brown, and then we've got combat, and then we're going to just run the sequence one after the other. We've got Brown agent, Jones agents, and we're going to just run those sub-agents though. If we wanted to see the combat, let's just go a little bit, sorry, the parallel. So let's go minimize that there. The parallel is using very similar to what we saw there. There's the parallel agent there, and it's going to say, okay, run them all at the same time. They don't depend on each other. So Brown, Jones, and Smith just says attack, just run at them there, and then get the results. And then we've also got, finally, the loop pattern there that runs the auto battle that just has a loop state to say, okay, cool, if you run this, and any given time, let's go there we go, parallel agent, if any of them actually wins, stop it. Neo's out for the count though. And there we go, Neo score, exit condition, Neo score or agent score. So if Neo gets more than 5, it'll output and it'll finish. Or if the agent if the agent just scores 1. So let's try that out. I'm gonna put Neo as the 1. I'm gonna reset there. I've run this once and it's very hard. So let's go auto here. And this is gonna call each agent to go and have a round there. Let's just see here, auto. Okay, no, Neo died. And I did Neo the 1 because this is chance. It actually randomized it. So let's go reset there one more time. Let's just see if we can get at least 1 round to actually work. And let's see here. And yeah, oh, yeah, okay, Neo wins all 3 fights. The 1 cannot be stopped. Okay, next round. Let's see if we can actually go to round 2 here. Oh no, Neo loses. The matrix is restored. Okay, so you can play around with that. It's pretty fun to actually go in there. And in summary, if you want to use the specific patterns, the sequential, simple pipeline with clear steps. Parallel is great, but they don't talk to each other. You need multiple perspectives fast. Loop, quality is critical. Time is not. It can take quite a long. We took 120 seconds. Different inputs, so conditional, different inputs need different handling. We saw how we can compress it and just run that workflow. Supervisor is complex tasks, unclear how to break them down. It handled the withdrawal. It handled the actual balance. It handled all of that. Human input, I got my horoscope, which is a great horoscope for Virgo. And then GOP, you have many dependencies. You need the optimal path, like the travel planner. And then also the P2P, creative brainstorming or collaboration. So here's everything that you need to do. Go play around with it. It's pretty fun. The app there for the matrix agents is there. You can just go in and use that AKA link. And there's the repo. Really go in and look at the code and see if you can get the auto battle. I've won once to actually win 5 times. The live dashboard, you can play around with that. You can go through all of exactly what I showed you there. It's actually on Azure, being hosted on Container Apps. You can go to the app, or you can actually go see what I did in the code. This was created in conjunction with the LangChain4j team. They actually helped me create it though. And I want to remind you that I am the author of LangChain for Beginners. It will take you from an introduction of what is AI, what is how do you actually use AI, prompt engineering, the basics of prompt engineering, and the 14 patterns you need to understand, retrieval augmented generation, tools and how to create tools, and then it's going to go through MCP and agents, and you can then go through the advanced agent patterns like I did with you there. And I'm